Okay, so we're going to review X and Y intercepts. Before we talk about how, and I'll look at all of the different strategies that we should know how to find X and Y intercepts, we have to remember what the X and Y axes are of a graph. And so if you remember, the horizontal axes going across is going to be the X axes, and the one that's going up and down, the vertical axes, is what we label as the Y axes. So talking about X and Y intercepts, we are saying where does that graph or function intercept or intersect with each of those axes. So an X intercept is where the graph crosses the X axes, and the Y intercept is where a graph crosses the Y axes. A few things to remember about these points is that regardless of where my point is on this x-axis, each of these points would be like this, 30, 0. This would be at negative 40, 0. This one here would be at, let's say this one, negative 80, 0. So regardless of what those points are, there's a commonality between all x-intercepts, which is that the y value is always going to equal 0. So an x-intercept is always going to look like some number wherever it crosses that x-intercept, x-axis, 0. Y-axes then, or looking at where we can cross the y-axis or my y-intercept. So if I have points here or here or here, so this would be the point of 0, 60. This would be the point of 0, negative 30. And this would be the point of 0, negative 90. Now, what's the same about all of those points is they all have an x value of 0. And that's all going to be common for all of my y-intercepts. So these are always the point of 0, some number. And so knowing those two pieces of information is important because, for example, if we were given a table of values like we're given here, we should be able to look at this table of values and say, oh, this is the x-intercept and this is the y-intercept. So what I can do first of all is, I'm looking for those 0 values. So if I look for this one right here, and I have this one right here. If I write those as an ordered pair, this is the ordered pair of 0, 6. And this is the ordered pair of 4, 0. And so looking at those now, this x value is 0 and the y value is 6. So this point right here would be my y-intercept. The one in blue, the x value is 4 and the y value is 0. And so because we have a y value of 0, that means this is going to be the x-intercept. I should also be able to, again, given a whole bunch of ordered pairs, be able to look at them and say, oh, the x-intercept is this value and the y-intercept is this value. So where does it cross those axes? Well, if I'm looking at this one, the 0 value is actually at 0, 0. And so that would be a point where the graph crosses through the origin. And so that means both the x and y intercepts equal 0. So let's go take a look at how to just look at a graph and find the x and y intercepts. Those should be pretty easy. So if I'm looking at this graph right here, which is a quadratic function, if I'm going to go try and find the x-intercepts, I'm looking at where does that graph cross the x-axis. So where does it cross this axis? Well, it crosses at right here, and it also crosses at right here. And so my x-intercepts here looks like it's equal to -2 and +2. I can technically also write those as ordered pairs, that this graph crosses through a point of -2, 0 and at 2, 0. I could also do that now if they ask me, what is the y-intercept of this particular quadratic function? Well, where does it cross the y-axis? Well, the y-intercept is right here. And so my y-intercept is at -4. So they might either say the y-intercept equals 4, or they can also express that as an ordered pair, which is 0, -4. Regardless of what kind of function I do, I'm just examining it and seeing where does it cross the x and y axes. So that's pretty straightforward, right? If I take a quick look at this graph, I can say, oh, okay, my x-intercept here is at 10, and the y-intercept here is at 5. And so I could technically write both as a point, 0, 5, and x-intercept is at 10, 0. And if I look at this left function, here's my graph. If it said, what's the x-intercept and y-intercept? Well, based off of the information that they gave us, if this graph was to continue down, let's say, because this is 5, so this is maybe like 4, 3, 2, 1. This here would be my x-axis. So this particular function doesn't even have an x-intercept. But it does have a y-intercept at, let's say, sorry, that's probably about 3. So 3, which is the point of 0, 3. So sometimes you might not have an x-intercept. Maybe you have 1, maybe you have 2. Again, same thing. Maybe you don't have a y-intercept, or maybe you have 1 or 2, which would make it not a function, but that's beside the point. So graphically, it should be pretty easy. You should be able to look at a graph and tell me what the corresponding x and y-intercept values are. Now, algebraically is one of the skills you should be coming in here knowing how to do is solve for an x and y-intercept, but let's quickly review that. So to solve for an x-intercept, well, what we had said before, the common trait for all x-intercepts is that the corresponding y value of an x-intercept, y is equal to 0. And so what I will do is, in the equation that we're given, we'll make y equals 0. Then you solve for x. Solve for x. So let's go look at an example below and just solve for an x-intercept. So my question down here is saying, algebraically determine the x and y-intercepts of each equation. So this should be a y. Let's change that. So they are asking me to solve, let's strictly just look at the x-intercept. So if I'm solving for the x-intercept, that's where y equals 0. So I will substitute a y equals 0 into this equation. So 0 equals 3x minus 4 times y, which we made 0, plus 12. Now, when negative 4 times 0 is 0, that's just gone, right? We don't really need to put a 0 into that equation to manipulate it. Now what I can do is I just solve for this remaining x. So to do that, I will move my 12 to the other side. So I'll subtract 12 to either side. Negative 12 is 3x. To get x by itself in this last step here, remember, when you have a number and a variable right next to each other, they're being multiplied. So to undo the multiplication by 3, we need to divide it by 3. And because this is an equality and we want to preserve that, what we do to one side, we'll do to the other. So x will equal negative 4. So that means there's an x-intercept of this graph at negative 4. There'd be a point at negative 4, 0. And so for any x-intercept, if I'm solving algebraically, substitute y equals 0 into the equation, solve for the remaining variable, which should be x, because you're trying to solve for an x-intercept. Y-intercepts then. So to solve for the y-intercept, if we remember what we said previously, all y-intercepts have a common value in which x is equal to 0. And so what I would do is, in my formulas, I'll substitute, make x equal to 0, then solve for y. So make x equal to 0, and then solve for y. So if we look at this equation right here, try to solve for the y-intercept of this equation, we need to make x equal to 0. So now, if I'm going to solve for that, I will go 0 equals 3 times x, which we're making 0 to help me find the y-intercept, minus 4y plus 12. Again, when we have 3 times 0, that's 0, so we don't need to include it anymore. So I'll subtract 12 from either side. So negative 12 equals negative 4y, and I need to get the y by itself, and those are being multiplied. So to get rid of multiplying by negative 4, I'll divide by negative 4 to either side. So I'll have a y-intercept at 3. So that's the coordinate of 0, 3. Technically, I could take that information and now plot that on my graph if I wanted to and sketch a line. But really, they're just asking us, what is the x and y-intercept? And we've solved that. So let's also take a look at B. B is in a little bit different form than A was. A here is in general form. And we got to do a little bit of work for general form. If I'm looking at a formula in this form, y equals, and everything is on the other side of an equation as we have here, whatever is the constant, which is the term without a variable, will be my y-intercept. So let's see if that holds true. So again, they're just asking me to solve for the x and y-intercept. So let's solve for the y-intercept first this time. We said the y-intercept is wherever x is equal to 0. So I'll substitute x is equal to 0 into this formula. So y equals 0 squared minus 12. Well, 0 squared is just 0, so we can ignore that. So there's a y-intercept at negative 12. So 0, negative 12. And so as I had previously said, if we're in this form y equals a formula, whatever my constant is, that will equal my y-intercept. If you forget that rule, you can always just solve algebraically by remembering to make x equal to 0. To solve for the x-intercept here, so to solve for the x-intercept, we make y equal to 0. So 0 equals x squared minus 12. So I need to solve for x, so I'd add 12 and add 12. So 12 is equal to x squared. When we're trying to solve for an x or y-intercept, we want x by itself. In this case, x is being squared, so we need to square root that. Squaring and square rooting something. The square root of x squared is x, and the square root of 12 is actually plus or minus 12. I end up with 2 answers there. Remember, whenever you square root a number, you get 2 answers. You get the positive and the negative. So for example, 5 times 5 is 25, but so is negative 5 times negative 5. So there'd actually be 2 x-intercepts here. There'd be one at negative root 12, 0, and one at positive root 12, 0. All right, that's it for x and y-intercepts.